Good morning, good afternoon, and good evening to everyone joining us from across the world for Teaching at the Right Level Africa's 7th webinar and our first webinar this year. I'm your moderator, Samyukta Lakshman. I am a senior manager at Pratham and a part of the Tarl Africa Central team. For those of you who are joining us for the first time, Tarl Africa is an initiative jointly led by the Indian education NGO Pratham and the Abdul Latif Jameel Poverty Action Lab, or JPAL. Today's topic is Mathematics Education in Africa, Challenges and Solutions. Incidentally, tomorrow, March 14th, is also International Day of Mathematics. We have an all-women panel today. Our first speaker is Professor Hamsa Venkatakrishnan. Hamsa holds the position of South Africa Numeracy Chair at the University of Witwatersrand in Johannesburg. Her work in South Africa has been in the areas of mathematical literacy and primary mathematics teaching and learning. Today, Hamsa will be speaking about the WITS Maths Connect primary project. Our second speaker is Nisha Ligon. Nisha is the co-founder and CEO of Ubongo, a leading edutainment company in Africa that creates fun, localized, and multi-platform educational media that reaches millions of families through accessible technologies. Nisha's presentation will focus on how Ubongo uses stories and songs to make maths more understandable and relevant to children's lives. Our final speaker is Meera Tendolkar. Meera is the Director of Maths Content and Training at Pratham and leads all numeracy instruction, design, training, and research at Tarl Africa. Meera will be presenting on the Tarl Maths approach. Some house rules before we start. This webinar will be for about 1 hour with a total of 30 minutes for presentations, followed by 30 minutes of Q&A. If you have any questions, please feel free to type them in the Q&A box, and we will try and select them during the Q&A session. Please specify which speaker you are asking your question to. So without further ado, over to you, Hamsa.
Hear me properly?
Yes.
Okay. All right. So my name is Hamsa Venkat. I work at WITS University in Johannesburg, and I'm going to say a little bit about our work in the WITS Maths Connect primary project. It's a research and development project that we've been working in for nearly 10 years now. So what's the problem in terms of maths in South Africa? Well, at one level, we know that we've got low performance at all levels, but that's a very broad statement of the problem. So I'm going to show you something which is a little bit more precise and affects primary maths. Next. So here you can see what I mean by the specifics of the problem in primary maths. You've got 3 examples on the screen, and they are examples all taken from different grades in primary schools, but the problem is common across them. You can see children trying to answer a range of different problems with incessant and highly rudimentary unit counting. And that's being used in the first example you can see on your screen, actually for a multiplication problem. Double-digit multiplication is being attempted with a very basic kind of unit counting. Now, it points to a lack of progression in primary schools, a lack of teaching for progression. So we have to understand what progression looks like. So if we go to the next slide. Looking at the literature and the research in maths education, they would talk about progression in early number learning, going through these kind of 3 stages. The first stage is the kind of examples I've shown you on the previous slide. It's called calculation by counting. And you can see the example in front of you. Those 2 questions have been answered correctly, but they've been answered correctly by a unit counting. A 10 is drawn, another 10 is drawn, another 10 is drawn. Then all those tallies have to be counted up to get the answer. In the literature, they would say that while children should start there, what we need to be doing in the early grades of primary school is to be doing something called calculation by structuring, helping children to work with and use number relationships to do mental calculation more efficiently. So the example you could see there, 38 plus 7, you can see that it's been answered not with 38 tally marks, but with a child who knows that they can start at 38 and bridge through the next 10, the nearest 10, which is 40 there, and use that to add more quickly. Another example would be something like 99 plus 99, which is a hard question to do if I'm unit counting, and not a particularly nice question to do if I'm going to use column addition. But actually, if I know my number relationships, I know that 99 is close to 100, and I can answer that question mentally quite easily. At the upper level and beyond that, in some ways, we have a whole range of harder calculations that children gradually move towards, and that's called formal calculating. It's written calculations, but we want those written calculations to be underpinned by a good number sense. So you'll see that if children have got number sense, they will be able to say, oh, 7 and 5, I know that that's 12. So I know that I can write that as 1, 10, and 2 units, rather than reverting there back to unit counting. So what is our project doing with this work? Next slide. Our project is a research and development project, and one of the initiatives within it is called the Structuring Number Starters project. And in that project, what we're trying to do is to design and implement interventions for improving the kinds of performance that I've shown you on the ground. We work with 10 partner government primary schools in the Johannesburg area. As I said, we've been going for nearly 10 years. So in the first 5 years of the project, we worked with 10 primary schools in Joburg. 5 of them were no-fee township schools. And in township schools, a range of different home languages are used as the medium of instruction in the early grades. We also worked with 5 suburban schools. And in the suburban schools, English is used as the medium of instruction from the start. We had phase 2 going from 2016 to 2020. And in phase 2, we worked with 3 clusters with 6 of the original schools going into the second phase. In the Structuring Number Starters project, we're paying attention to calculating by structuring, that business of using number relationships. The model is that we design tasks, we prepare resources, and we work with key representations alongside a teacher support package. Next slide. Here's an example of the kinds of tasks and resources that we've prepared. And you can see there that this is part of a learner workbook where there are some worked examples on the top. There are some notes for teachers on the kinds of things that they should be writing on the board when they work with examples like this. And then there are some practice examples for children to work with. Next slide. And here's another example. And in this one, you've got an example that's working with 100 square. And aside it, you've got the kinds of notes that we give to teachers. This gets kicked off with a workshop session where we work with teachers in a school or in a small number of schools. And we allow time for teachers to get used to the notes, to get used to the resources, to get used to the kinds of things that they might have to say in home language in their classrooms, or in English language if they're in English language classrooms, while they're working with these resources. Next slide. Now, what we want to do along the way, we've been working for a long time, we want to measure impact. We want to know whether the work we're doing is helpful. And for that, we need some kinds of frameworks and codes to be able to think about. Now, you've seen in the work that our interest is less in whether children can get the correct answer and more in how they work to get the correct answer. So what we've been using is this little framework developed by a group of Australian researchers who developed a program called Maths Recovery, used in Australia, but used in other countries as well. And they talk about this increasing sophistication in children's working with early number. I'm not going to go through all the stages here, but I will point out that at stage 2, they talk about counting all, and counting all means on early number problems like a 4 plus 3, a child at the count all at stage 2 will take out 4 fingers, count out 4 fingers, then count out another 3 fingers, put them all together, and then count from 1 again to get the answer. So that means you've got 3 separate counts to get the answer to a question like that. By the time you get to stage 3, we're talking about counting on. So on that same question, a child would say, oh, well, I can put 4 in my head And now on my fingers, I'm going to count another 3 and I can go 5, 6, 7. It's still counting, but it's a quicker counting than stage 2. And then the upper stages are important because this is where we start to get children working with either number relationships or saying, oh, 4 and 3, I know that that is 7. So these stages are important because they talk about more sophisticated strategies as we go up. Next slide. So this is just an outline of what we were doing in schools and where we've collected data. We've been in schools across the last 8-9 years. So in 2011, we did some interview-based testing with children. The nice thing with interview-based testing, with a little video camera, when you ask children, you can actually see if they're using their fingers to count. So we've been testing, we collected data in 2011, 2014, and 2018. And I'm going to share some of the results now. Next slide. So in 2011, when we started, what we found with the sample of learners, their cross-attainment, and we asked the schools for 2 weak, 2 moderate, and 2 high-attaining children in their schools. So we tested 36 children in the 6 schools that we've worked with all along. You can see in 2011, when we started, 3/4 of the children early in grade 2, we're looking at 7-8-year-olds, are at the most basic levels. They're counting all at best, which means that only 25% of the sample that we worked with were actually at the upper levels of counting on or higher. That was what we saw in 2011. Next slide. In 2014, what you can see is that that proportion went up significantly. So now we've got coming up to 2/3, 61% of the children, up a lot from the 25% we began with, are at those more sophisticated levels. They're counting on or better. In 2018, that proportion has gone up a bit more. It's now at 2/3 of the learner sample are able to either count on or work at the more sophisticated levels. Next slide. But if we go up to the higher bracket that we were looking at, which is using number structure or working with recalled facts, we get another slightly different picture. In 2011, there were almost no children, less than 3% of the children able to work at those higher levels. In 2014, that had gone up a little bit. It had gone up to 5.6%. But in 2018, that figure has gone up quite substantially to 25% of the learner cohort. Last slide. So that's the overall pattern that we've seen in the time that we've worked. Those differences over time are statistically significant for the people who've interested, but the headline message is that in the project, we have seen that supporting teachers' attention to efficient working in waste in number does seem to have produced differences in the profile over time. Thank you very much.
Thanks, Hamsa. Next, we have Nisha.
Hello, everyone. So I'm Nisha from Ubongo. We create edutainment for kids in Africa. And I'm going to tell you a bit about what we do and then move quickly into talking about how we address some of the challenges we face, hopefully that are relevant for people who are working to teach math, whether or not you're using media. So I think all of you understand the huge scale of the problem that we're facing in sub-Saharan Africa, where we really do have an education crisis, especially in areas like mathematics, where very few children are reaching proficiency. And we have now 500 million kids in Africa with an expected 2 billion to be born over the next 35 years. So it's a big urgent problem that we need to address very quickly. So our way of doing that at Ubongo is to leverage the accessible technologies that families across Africa already have access to: radio, TV, and basic mobile phones. And these allow us to deliver high quality content, localized content to kids at low cost and massive scale. So our model is all about using the power of entertainment. So how do we get kids interested to learn? How do we get them pulling this learning of math content instead of us always having to push it to them. Then we also use the proven efficacy of having localized content, local language content, or locally relevant content that might be in language of instruction. And then the huge reach of mass media so that we can bring this out to millions of kids at a time. We're proud to say that we have now the largest, what we call the largest classroom in Africa. So we have about 17 million families who tune in to watch with us on TV or listen in on radio every month, and we're growing rapidly. We currently have content in 6 languages, and we're working on many others and trying to make sure that we can get this supplemental informal learning to kids across Africa very quickly. We do have, oh, actually, before we get into that, I'll show a quick video because I think it's easier to just kind of see some of this rather than me just talking about it. So if we can play the video.
Friends are so much fun. Let's sing this song. I sing this song. My name is Mary. Hello, Mary. I am 5 years old. 1, 2, 3, 4, 5. Where does the button go? Circle, circle. More, and you have less. I give you some of mine.
So I apologize. I don't know if the video is lagging for other people, but I can just describe a little bit, I guess, as we see it. So we do really locally relevant math. Try and make math concepts locally relevant. So if we're teaching, say, something like skip counting, which you can see in one scene here, we have a song. We have kids skipping over rocks or skipping over stairs and skip counting as they go. We do, here we've got, you know, more of a rote counting song. We do patterns. We do these in different languages and try and make sure that we make the content really adaptable so it can go into all different languages that children would use. This here is our older kids show, Ubongo Kids, which has slightly more advanced math. So if you could see what was happening there, that was some content on place value. So counting rats and mice living in big skyscrapers with 1,000 per skyscraper, or smaller buildings with 100, small houses with 10, or individual houses with 1, and understanding place value that way. Here is doing kind of higher level addition. And then this last one, which I wish you could hear, is a fun traditional Taarab song teaching about decimals and place value. So by using these really fun, engaging methods that we actually co-create with children, we're able to make sure that we're doing things in a way where it's this kind of pull learning. Kids are really excited to learn about math, and they don't, it's not just us kind of trying to force them. It's really exciting to know that, you know, you might have 17 million kids waking up on a Saturday morning to learn a thing or two about algebra. Now, we have shown that this does work, but of course, we're not saying that it's an alternative to schooling. This is supplementary. But in early numeracy, especially things like rote counting and shape recognition, we've had really strong results with treatment groups scoring 24% better after a month of daily viewing than control groups who were watching alternative cartoons. With the older kids' content, we also see significantly higher scores on standardized math assessments like the Uwezo assessment that's done across East Africa. Now I'm going to talk real quickly about some of the challenges that we face and how we're overcoming those that will hopefully be relevant whether you're using media or doing face-to-face teaching in the classroom. So the first one is, of course, this issue of language, and how do you make sure content is being delivered in a language that kids understand? In sub-Saharan Africa, we have over 1,000 languages. And so this is a real challenge for us. And it's not just about creating good content and then assuming that someone's going to put it into local language. Often we actually find that there is not the vocabulary available to teach about things in math, such as here we have equivalent fractions. So our original language is Kiswahili, and it's really rich actually. So we have words like sehemu huafikiana, which would be an equivalent fraction. We have words for numerator and denominator. But as you see on the right side, actually, we have to actually switch over to English or sometimes French for other countries where the local language that we're teaching in really doesn't have an appropriate word to use to describe these concepts. And it would just be kind of creating extra work to try and come up with a word that no one understands to say this, as opposed to just using the English or French word instead. Next slide. So I've put up a couple of other examples of where it's really important to consider language. So with isiZulu, as you can see on the left side, as you get up to numbers like 7, 8, and 9, these are really multisyllabic long words. And if you're having children doing mental math using these numbers, you have to consider that it actually does take them significantly longer to do things like mental calculations just because of the amount of time it takes to say the word. It's also an issue for us using math songs, because a line like, hey there, number 9, are you doing fine? Instead of all those words in English, we would just be still saying the number 9 in Zulu. In Chichewa, we've run into something where we would say in English, 3 bicycles, count them 1, 2, 3. But in Chichewa, they use the local Chichewa word for an amount of something, but would then count in English. And that is the standard. So we'd say Njinga Zitatu, 1, 2, 3. And there's kind of a different level of explanation and learning you would need for a child with that. For Kiswahili, sometimes things aren't super specific. So the same word, so elfu kumi na moja, can be 11,000 or 10,001. So we have to take this into consideration when we're translating and make sure we're being really specific. And then it's not only higher level concepts. So for Yoruba, Igbo, and Luo, we've found that there's not standardized words for talking about shapes like squares and triangles, though most languages seem to have circles. So the word for a square would just be saying it is a shape that has 4 corners and 4 equal sides. So we've had to make some conscious decisions and work with teachers around this to figure out, okay, are we going to make a decision to say, teach the word square in English, but then use local language to scaffold the understanding of what that word means. Adaptation and localization also goes beyond language. So on the next slide, you'll see that one of the classic ways that we like to teach math is by using examples of money. But the same example would be an easier math problem for a child in Ghana, where you would use something like 10 or 20 cedis, versus in Uganda, where, for basic purchasing, you're already talking in terms of 10,000, 20,000 shillings, not to mention, of course, Zimbabwe, where we get up to billions and trillions, which can help us teach very different topics. The next challenge that we face quite a bit, and I think teachers who have large classrooms also will see this, is how do we make this interactive, right? So we essentially have a one-way stream of communication with kids, and we don't want them to just be zombies sitting and watching a screen. We put in a lot of work to make sure that even though we're kind of doing a one-way broadcast, we design things so that they pull children in and can be really engaging. And I think it's important to think about these kinds of methods too when we're talking about a teacher maybe teaching to a huge class size of over 100 children. Some of these same methods can be used. So these are some user testing pictures from, we'll do kind of hidden camera testing of kids watching the videos, and what we want to see is them jumping up, dancing around, following instructions, pointing at the screen, and of course shouting out the answer. So there are some really basic things of just like engaging with them at, say, pointing at the answer, even if, you can't do individualized instruction with one child at a time, that answering a question does activate a different pathway for learning, and that's valuable. I'll move quickly through the rest of these. Slide, please. Making really specific examples that are things that kids could do themselves at home, having them work through problems that they see on the screen and giving them the time to do that while keeping it engaging. So The next page is using, say, a scene to sort different ways. So we sort by color, we sort by shape, etc. And have actual kids' voices on screens where they're shouting out the answers. And then something else we've been trying to do is for older kids is actually do surveys and collect data and feedback from kids and then analyze it and feed it back to them. So these hosts, Melody and Amy here, have been polling kids. They send in their answers from their parents' phones via SMS. And then we feed back and say, hey, here's what you said. And we use that as a way to make the math we're using here of percentages more relevant to them. Next slide. And then the last question, and I saw this came up in the questions that were being asked, which was, how do you get this to the kids who need it most? And I think I can address that more in questions, but what I'll say is really quickly, we're really focused on supplemental learning outside of the classroom, but we're excited to partner with people like here with UNESCO to figure out how do we bring this content into classes or to reach the most vulnerable kids who wouldn't have access to the platforms we use like radio and TV. We have recently launched, on the next slide, you'll see a free toolkit where all of our content is now being put under Creative Commons non-commercial license. So anyone can go here, sort through content by type, topic, age, language, and download these materials. And we're working on scaffolding and support materials for teachers too. So trying to figure out how we can make this more relevant for classroom use and looking for feedback on how to do that. My time's up, so I'm gonna let the next presenter go. Thank you very much.
Thanks, Nisha. Up next, we have Meera.
From Pratham Education Foundation and TAL Africa. So today I'm going to talk about what teaching at the right level MAC do and what are the challenges we face in implementing the program and what are the solutions. Next, please. These are the contents I will cover in my presentation about the TAL and what TAL mathematics we do, what are the problems, and some example of number recognition and operations. Next, please. So in short, I will talk about what is teaching at the right level. The crux of the approach is grouping children in grade 3 to 5 according to their learning level. And we focus on the foundational reading and mathematics, targeting instructions we do. We also, the most important thing is the periodic one-on-one assessment we do. And that is to help to define the learning levels, which also to direct take a decision making on the classroom level, school level, and further on. TAL was developed by Pratham in India and is currently being implemented by governments and NGOs partnered in 12 African countries across Africa and 3 countries across Asia. Next slide, please. These are the key elements of TAL math. Periodic assessment, we do baseline, midline, endline, and that help to understand what is the progress children are doing, and it help to compare the result and do the planning according to it. So level-based grouping is the most important thing of the TAL, where we divide children based on their level, not by grade. And it helps to teach children what they learn, and based on that, what further we need to teach them. Pedagogy actually mainly focusing on the capability of the children, which we call the TAL principle, which are listening carefully, speaking, thinking, doing, writing. All these elements actually help children to learn maximum. So we call it combining activities for maximized learning. In short, it is a command. And activities mainly happen in the whole class and in the small group, sometime in the individual. So small group is, I'm talking again because it's a very important to the children learn mainly with the peer learning, with each other. The children who don't talk in a whole class, they can speak in a small group. So that is why we are focusing also in the group. Mentoring actually make a huge effect on the TAL program, mentoring from the higher level to school level, which is supporting team, which also be a part of the teaching at the right level. Okay, so these are the key elements of the math. I will talk about what are the challenges children face at the time of math. Okay, so first of all, everywhere common, not only in Africa, everywhere, that why this fear comes. Actually, it transfer from adult, mainly from parents and teacher, because they sometimes tell that this is very hard subject, you have to work hard, you have to study hard. And in some of the African countries, even in India, we saw the teachers also doesn't have a confidence to teaching them some operations like a multiplication and division. So that also goes toward the children. There is also a lack of connection between the abstract and concrete. Some of the children, for example, the children who are out of school, or those who sell some product, they can do calculation mentally. But if you ask them to solve something in the notebook, they can't do. Similarly happen with the school children who goes in school and they doesn't know what is the actually daily life mathematics. So it's necessary to connect both the things together to give them a conceptual understanding. One more important problem we face that about the counting the numbers. Children do counting with the tally, but that doesn't mean that they know the number. They can count number from 1 to 100 or more than 100 also. But if we randomly ask to recognize any number randomly, they stuck on it. So and also this is follows with the understanding of place value, which help them to learn more the operation. So these are the things actually children face. Even the connecting with the daily life example, they know how to handle currency, but actually they don't understand this is actual mathematics. So that's a lack in the learning. And also the enough they don't have a exposure to process and encouraging mentor for practice. So that is the these are the problems, and some of the problems we are trying to cover here, which we mainly focus on numbers and operation. Next please. As I said, in number recognition, children have a problem in understanding number. They just do the counting. So there are some activities we created with the number chart, some games like a number wheel, jumping on the number. So for example, here is the number chart, which we ask children to read this number chart, not counting, reading the number chart by putting a finger under every number. And it is not only in a sequence of 1 2 3, but they can go horizontally, vertically, randomly. So even we can ask any number in between to read, they should recognize it, they should read it. So this is how we are using this number chart. There are several activities which is help them to immediately understand what is the place value, what are the tens and what are the units. Sticks plays a more important role, making a bundle of tens. We sometimes also use currency to teach them a bigger number, more than 100, thousands also. And all these efforts to teach them place value comparison help them to understand what is the operation. Because at the time of operation, what are the, from where we have to start the operation, that's a big problem for children. So it is very, very important they should understand what is number recognition and how it to understand. If TAL is mainly focusing on grade 3 to 5, and these are the children have a at least 2 years experience. So it doesn't mean that they don't know anything. They are familiar with some of the things. We are focusing, TAL is focusing to take this familiarity toward the application. So familiarity, understanding, and application, these three things goes hands on hand with the activities of TAL. Next, please. Operations are the big problem in Africa we saw. Even in number recognition, when we compare with India and Africa, the number recognition sometimes children doesn't make face problem, but yes, in operation. I don't shown here any percentage, but we observe that around 80% children of grade 3 to 5 are facing a problem in addition and subtraction, even an addition and subtraction at the time of baseline. So this is mainly when we saw that children doesn't have a practice of writing anything or handling something with their to do the operations. So we start our operations with the word problem. Here I have given the one example that Paul has 14 mangoes. His mother gave him 15 more mangoes. How many mangoes does Paul has now? So such a kind of an example which children are more familiar with them. We use children's name, those who are present in the class, and write the example on the board. Teacher used to read this carefully and loudly so everyone in the class can listen that example. And then she asked some guided questions. These are the guided questions which are very important. What information is given in this word problem? So, so this is not a one side interaction happen. Both the side interactions start happening. Children start giving their whatever the answer. What is the information given? What is asked to do? So here also children start thinking about, okay, I have to think about what should I have to do? Do I need to add these mangoes or do I have to subtract these mangoes? What operation do I have to do and why? So all these kind of questions, when teacher discuss with children, half of the problem children understand immediately. After that, with the help of some material like sticks or currency, we ask children to solve it. So it's learning by doing happen actually in the class, and this without giving any abstract number like 14 plus 15, there is no meaning for that, So when you add some example with that, children understand it very well. So this is how and this is not only for the addition, we also use it for multiplication, all kind of operations. We start with the word problem. These are the examples, some of the I have given here. Country by country, everywhere, they have a different type of writing, the division. And in that, we also think about what are the challenges they face. For example, in Zambia, they write division, but they don't write the lower part of a subtraction. So sometimes children get confused, So that is why we decided that in TAL, all the things should go in step by step and everything we should discuss with children. Thank you very much. I am finished.
Thanks, Meera. So now our listeners sent our speakers some questions ahead of the webinar, which we've selected. Kim, can we have the first question, please? So the first question is for Hamsa, and the other speakers are very welcome to answer this as well. I'll read out the question for you. How significantly does the fact that most students are taught maths in the medium of instruction rather than their home language affect their ability to learn maths? What are some of the findings of the SNS project which used both home language and English to teach maths? Hamsa, this is a question for you.
In South Africa now, currently, in the early grades, certainly the majority of children in the early grades of primary school are learning mathematics in their home languages. So the problem is not fundamentally medium of instruction per se in South Africa. I think what is more likely the problem in South Africa is that we have lots of teachers who are not used to teaching mathematics through the home language. So in the project, what we have tried to do with the training and the kinds of materials that I've shown you, and similar in many ways to the kinds of materials that Meera has shown you as well, we do provide time for teachers to get used to the materials. And what that means is time in workshops for teachers to grapple with the contents for themselves, but also to practice speaking the content in their various home languages. And in township schools in South Africa, we will often have two isiZulu classes, a Venda class, a Shivenda class, a Tsonga class. So there's time in the workshop for teachers to teach each other, and in the process, learn to get familiar with how to communicate that content in their home languages. And we found that helpful. It builds confidence, and it also then it makes the teachers more willing, we think, to actually work with the content in classrooms, having had some time to engage with practicing, building their own home language repertoires in relation to the mathematical content they're trying to teach.
Thanks, Hamsa.
Can I give my answer?
Yes, go ahead.
Yeah. So yes, of course, the home language makes lots of changes in children's life, because, as I said, the word problem, we not math is actually a universal language, but for teaching with the word problem or to discuss with children, definitely home language may create a lots of help, give them a lots of help. Yeah.
Yeah, I would really agree with that. One thing that I would throw in that we found with, since we're usually operating outside of schools and supplementary content, is that there's often really strong demand from parents for language of instruction content, even if they don't understand it and the children themselves don't. So even though we have a lot of evidence to show that learning in home language is really valuable, we also know there's high demand from parents that's the opposite, which is let's make sure that children speak, say, very good English. So we've kind of moved towards doing content that is bilingual, or at least marketed that way. So it's like children are learning English from, say, Hausa or Kikuyu or Luo. And what's been really interesting to us is the feedback that we actually get from parents, usually through social media, where they will say, wow, I never understood that concept, or I really never understood why math was relevant to me until I started watching your shows with my kid and was able to learn this topic, say, in Kiswahili or Kinyarwanda. So it's interesting where I think there are some barriers even to home language instruction, but that kind of experiencing that for yourself can help bring some of them down.
Great. Kim, next question. All right. So this question is for Nisha. Given the hype surrounding 4IR or the fourth industrial revolution, is there some common sense, reasoned advice you could provide that doesn't pander to gimmicks, fads, and gadgets that will help mathematics teachers respond to the 4IR pressure? Also, what factors need to be considered to ensure that technology and audiovisuals are used optimally to teach math?
Yeah, so I think there's really two different elements when we talk about, fourth industrial revolution or ed tech that often get confounded and confused with each other. One is this question of how do we use technology as a tool to, be able to better teach, be it to alleviate some of the burden of large class sizes, to be able to present something, say, in a more visual way that's hard to explain. And that's kind of what we as Ubongo are doing in the home, where we're saying, hey, we're using technology that's already in the home to try and deliver quality teaching. But we are very technology agnostic. We just say that tech is a tool, whatever tech is there, we're gonna adapt to try and use it. And I think that that's one really important thing for teachers to keep in mind, or not, it's not always the teacher's decision, but say maybe a school system, that technology is just a tool in the way that anything else, be it a book or other resource would be. And what we have to evaluate is that tool appropriate and the best way that we can teach whatever it is we are trying to teach. So in this case, math. So that's one side of it. How do we integrate technology, say, into the classroom? And to be honest, we're only starting to do that. We've really been focused on technology in the home environment and are just starting to work with partners now to get it more formally into schools. And there are definitely a lot of issues with that. And we really recognize that it's definitely not a silver bullet or a cure-all. Then the other side of the conversation around fourth industrial revolution is about how do we prepare children for this rapidly changing and technological world. And in many cases, especially with subjects like math, that is very different from using technology. And I think it is a lot less about, oh, did a child get a chance to use a computer or a tablet in the classroom, and more about, are we teaching them the skills that are going to be necessary to be capable and competitive and thrive in this new world? And so you don't actually always need technology to do that, right? So we think it's more important to teach computational thinking. So how do we think around codes and problem solving? And we do that in ways that don't even, we never even talk about a computer. We use leaves and we have bugs making codes and algorithms with leaves. And we teach that kind of thinking. And I think that's really important, and teachers can push back there too, where like the skills that are important are not how to use a specific technology, because in 10 years that technology will change. They are the critical thinking and problem solving, especially within mathematics of, okay, well, I shouldn't just be memorizing formulas because Excel can do all those formulas for me. I can comprehend, as Meera was saying, a word problem and actually understand what do I need to do to solve this problem. And then if we're building that kind of a mindset, whatever tools we use, the kids will be able to adapt to that, because the technology of tomorrow is still going to be different from the technology of today.
Okay, Kim, next question. So this one's for Meera. To a large extent, teaching at the right level is targeted towards helping children who were left behind to catch up. What should we do to have children learning things when they're supposed to by curriculum design, rather than waiting to give them a push when they are stuck?
Okay. So first of all, I want to say that the children, TAL is covering children who are grade 3, 4, 5, right? And if the children, we are saying that they're supposed to be by curriculum design, then, it's necessary to start from grade 1 and 2. But most of the children, more than 50% children who are coming to grade 1 without any pre-primary education. So that also affects, and when we are talking about the curriculum, math, the topics TAL is covering are the foundational skill of the mathematics. So without that, if teachers, or if we try to cover the curriculum in the class, the children will not understand anything. They will get lost. So I think it's better that every grade, wherever the children teacher find that children are actually facing a problem, it is necessary to push them in their basic competencies. Without doing that, teaching them the curriculum is actually nothing for children. They will be lost. They will not understand. And after that, maybe after grade 5 or 6, they will start losing the school. They will leave the school. That's kind of a problem can start creating. So it is very, very important that teachers should focus also on their basic competencies, just not blindly follow the curriculum.
Okay. So this question is for Hamsa. And Hamsa, I'm going to also ask you one of the questions that came in during the course of this webinar. In South Africa, we have seen the introduction of the Teaching Mathematics for Understanding framework. What are the key propositions of this framework? And is there any overlap with strategies or programs such as the SNS project? If so, what are they? And one of the listeners sent in a question about how do you explain the little percentage increase from 2014 to 2018 in the number of children able to calculate compared to the huge increase between 2011 and 2014?
For people who've read the American work on strands of mathematical proficiency, that mathematics is not only about procedures, it's also about conceptual understanding and reasoning and problem solving. So those are the fundamental principles, that mathematics goes broader than just learning procedures. They're the fundamental principles underlying the TMU framework. In terms of the overlaps between the SNS project and the framework, having looked at the materials coming out there, I think there is overlap in terms of some of the things that I talked about, like attention to structure, and particularly place value, decimal structure. So the relationships between numbers in the system and the tens numbers, the multiples of 10, which is a really useful thing for more efficient calculation. So I think there's certainly overlap there between the materials that we are preparing for the starter part of the lesson and the work that children will go on to do in the main part of the lesson, perhaps linked to the TMU model. There are differences as well, though, and I think what we have done in our work is paid more attention and more emphasis on efficient mental calculation, whereas the TMU is more focused on getting children quickly into formal written calculation and perhaps the more traditional algorithm type working. I don't think they're completely incompatible, but at the same time, they're not completely compatible either. And there are, as I've said, overlaps which I think are helpful, particularly related to base 10 thinking and decimal working and preparing for working with the decimal system. In terms of the follow-up question that you asked, we still have, and we have, there is very little special needs provision in South Africa. So even at this point, you know, and we are now 9 years in, we're still seeing a stubborn proportion of the population in schools who are still at that very basic counting level. It's sitting at about a third now, which is a great deal better than the 75% that we saw earlier on. Our sense is, and this is as things like the national workbooks and TMU framework come in, that proportion will come down a little more with the work that we are doing and linked to the work that's happening in the policy landscape. We think it can probably come down to about, it's sitting at about 33% now. We think we can probably bring it down to about 25%. That 25 to 20% is interesting because if you look at very much the developed world, there is American data and data from other parts of the world, which would say that they are, in American context, there's research which suggests that about 20% of the school population, particularly in disadvantaged areas, are struggling to move beyond that rudimentary basic unit counting. So I think we've still got some move to go, but I think it's unrealistic to say that that figure would come down to a 0%.
Okay, thanks, Hamsa. Kim, the next question. So this is for Nisha. And Nisha, I'm going to also ask you a question that came in during the webinar. So the first question is, how does Ubongo shift from product focus to focusing on the correct process in maths instructions? And the second question is, you mentioned that you use radio. How are you adapting programming for the radio in a way that doesn't rely on visuals for teaching math?
Sure. So how we shift from product focus to focusing on process, what I would say is that we definitely design with a focus on process and then adapt the product from there. So we have kids in our office 2 to 3 times a week, actually, and we're constantly prototyping the way that we're teaching through our visual and audio media to try and get to an outcome. And a lot of that is focused on process. And it was really interesting to see what Meera was talking about, we use so many of the same strategies actually through videos of, figuring out, okay, we know that children can do rote counting, but how do we get them to now start at 8 and get up to 9, 10, 11, or pick a number out of the grid and know what that is. So that's the way that we do it with a child-centered focus. To be honest, if you're asking this from the teacher point of view, how do we focus on teaching process to teachers? That is actually not something we've done yet. Informally, we know that teachers pick up on this from the way that we teach direct to kids through media, but it's not yet something that we've done formally, and we're really excited to work with other partners to try and do that. The question on radio is a good one, and sorry, I went a bit fast and didn't go into this in detail. At the moment on radio, we only have very early numeracy content. So our pre-primary series, Akili and Me, has a radio version, and we really focus, it's mostly numeracy through songs, and we do a lot of things like clapping. So if we're looking at, of course, rote counting, we're practicing the rote counting, but if we sing about, for instance, one song goes, these are 2 beats, and then you hear 2 beats and you count them, 1, 2. This is 4 beats, and you do 1, 2, 3, 4, and then we will have it both with the verbal counting and then also where the kids are just hearing the beats and they can count on their own. So that's something we test a lot. For the older kids content, where we're doing things like percentages and division, averages, statistics, that we have sadly not yet found a way to do effectively through radio, and we focus more on life skills and language skills on radio for that age of kids.
Great, thanks, Nisha. So this question is for Meera. How does TAL relate to teachers' support in their regular lessons? What would be the support given to teachers in between trainings?
So TAL, the activities are mainly focusing on their skills, So sitting in the group, learning with each other, with the activities, interaction. So all these skills definitely teacher can use in their regular, while teaching their regular lesson. Because all these skills, when we, mainly for the mathematics, when we see their textbooks we provide to every child, but actually these textbooks are not child friendly. So children never feel it like this is our textbook. So so the activities or the skills what when TAL talking about, it helps children to actually look into the textbook, and they should also feel it like I can do it when they sit in a group. So definitely this kind of skills will help teachers to support in their regular lesson. We actually have not done training for that, but yes, in between support is very, very important. Like what kind of things they could do at the time of teaching other higher competencies. As I said earlier also, these operations and numbers are the foundations of the all kind of further competencies. And if they focus on it, simultaneously, if they start teaching them a further competencies, definitely that will help teacher to overcome the problems what they face to teach them a higher competencies in the class.
Okay. So great. We're at time, everyone. Thank you, Hamsa, Nisha, and Meera, for your wonderful insights. Thank you to everyone for listening in and sending in your questions. A recording of this webinar will be available on the Teaching at the Right Level Africa website within the next week. We organize these webinars every few months. Some of our previous webinars have been on maintaining the quality of education at scale, teacher training, mentoring, and monitoring. If you would like to stay engaged and know more about TAL Africa, please subscribe to our newsletter. The links are up on the screen right now. Thank you. Have a great weekend and happy International Day of Mathematics.